This video is the companion to our full-featured article in Astronomy for Change. Link in the comments section below. James Webb Space Telescope image suggests rapidly rotating black hole in galaxy center. Welcome friends, Dr. Jim Daly, your host here, to present a series of images and how we produce them. Images that suggest the presence of a rapidly rotating black hole at the center of NGC-1365, New General Catalog number 1365. While we all know that JWST would answer many questions while posing new ones, that it would dispel some myths and uncover some mysteries while creating new ones, that we would acquire images that would open up a whole new level of detail about the universe to study, we really had no way of knowing just how incredible that detail would be. What am I talking about? On July 12th, NASA, along with representatives of the European and Canadian space agencies, partners in the mission, unveiled the results of 5 separate studies, images and data with a high wow value. The images released were impressive, with detail and resolution exceeding expectations, not just from the engineers and mission support specialists who have worked since Christmas of last year commissioning the telescope, but from all. The 5 studies released by NASA were meant to showcase the power and capability of JWST. This is not to say that other missions with a more scientific and astrophysical nature weren't completed. They were. And that brings us to the present moment. Some of these observations were part of NASA's ERO program, Early Release Observing Program, ERO. Some were not. Those observations that are not part of the ERO program are embargoed for 12 months from the date of observation. All data and observations are in the public domain. However, some are held in a protected priority status for an observing program's investigators for 12 months from the date of observation. The embargo allows the investigators to publish their study without undue influence or duress. We will present and discuss the August 13th observation of the Barred-Spiral Galaxy NGC-1365 that was part of the Early Release Observing Program. A barred-spiral galaxy contains a structural bar of stars, gas and dust that transects the galactic center, connecting one side of a galaxy or spiral arm with the other. In the case of NGC-1365, the length of the bar is over 99,000 light years from one side to the other. This distance is comparable to the diameter of our home galaxy, the Milky Way. The inner core region of NGC-1365 is 13,300 light years wide, or 7.5% the length of the entire galaxy, or the entire bar, I should say, of the galaxy. If our location in the Milky Way relative to our galactic center were superimposed on the image, it would lie midway along the bar between the core and the star-forming arc along the eastern edge of the galaxy. Known as the Great Barred-Spiral Galaxy, NGC-1365 is a barred-spiral galaxy 55 million light-years distant in the southern constellation Fornax and a member of the Fornax cluster of galaxies. We see that galaxy today as it was 55 million years ago, 10 million years after the dinosaurs went extinct. So that light that the James Webb Telescope recorded now to produce these fantastic images, that light left 55 million years ago. We're seeing that galaxy as it was only 10 million years after the dinosaurs became extinct. Something to think about. So a telescope allows us to become time travelers. We can look across vast distances of space, but also time. Of the 5 instruments on Webb, the one that acquired these images of NGC-1365 was NIRCam, or the Near Infrared Camera. We obtained the image data directly from the JWST data repository at the Space Telescope Science Institute and processed it using PixInsight and GIMP.